Welcome back to the next part in the series. So we are on to another board set number 7. And I have it powered up, and this is what we have. This is what we're starting with board number 7. It looks like nothing on side A. Side B, we're missing green. So we are missing green, and we have black screen. We have black screen on side A. That's already screaming bad RAM again, and probably a bad op amp for this green. So let's take a look at the board. Remember from the last, I think 2 videos ago, we did inspection. So let's get down here. We'll get kind of zoomed up on the scope. Let's probe around a little bit. I'm not going to show side 2. Side 2 is down here, but we have nothing on side 1. So let's just start probing around the CPU area. Let's hit some of these address pins, starting at 4, pin 4 on the CPU. They're all kind of, just I have my scope on 2 volts per division. Ooh. Let's go to 1 volt per division. And let's see what we have when we start probing around. Yeah, this CPU is not doing anything. There's the address lines. Excuse me, pardon me. Just kind of going down through here. Let's look for our clock. Let's find our clock here. So we do have a clock on the CPU. Do we have a clock? We have a clock on the PPU. Let's look at the running. Let's look at the running side. So Excitebike, this side is running. So let's look at some of the data and address lines on this side, on the PPU. There's our composite. There's our red, blue, and green. So we know we have color output here. Let's check the RAMs. These RAMs are going to be dead too. The video RAM. Yeah, the video RAM and the program RAM. We have nothing. We have nothing. This whole site is dead. No data. No addressing. There's nothing happening here. Okay. I think that's enough for me. From the other videos, kind of already know. So I think I have the desolder gun. Let's pull this 5533, test them now with the no green on side 1. All right, so let's check out the video circuit here, and let's probe around a little bit together. On the green on side 1, something's going on here. So let's see if I can. So on the schematics, this is our video circuit here. So green. Our green is here. So let's just see kind of what's going on here. Where green comes from. Pin 15 of the PPU. So let's check pin 15. Let's see if we're getting green out of the PPU. 9, 8, 7, 6, 5. Oh, I have to zoom out again or go up, one of the two. Yeah, looks like, we have green. We have green. We have a composite signal. I'm not sure how well you can see it. We have a composite signal. Probably put it like that. We have green coming out. Now let's drop back down to the schematics and we'll probe around. What are we gonna do? I'm already thinking it's that. I'm already thinking it's the 3P. I'm thinking it's probably this already. But let's probe around a little bit. Let's follow green in to Q14. Let's see, it comes into Q14, Q19, and Q17 is the final output for green. So let's find those on the board here, and let's probe around a little bit. So I'm going to try to get you guys where we can see the scope and kind of where I'm probing around. If I can get this guy any closer, I can zoom in better. All right. So the green section, player 1 green, is going to be on this side right here. Get some light over here too. Okay, what do we got? We got Q4. Okay, so here's Q14. Here's going to be the base here should have our composite. Let's see, comes in on the base. Green comes into the base there. It looks kind of different from that. Are we hitting we're not hitting any resistors or anything. There's green coming out of the PPU. So, okay, this is green. Q14, let's see, base. Collector should be just base, emitter. Collector should be tied low, which it is, emitter, and collector, or yeah, base and emitter. Okay, that looks okay. Let's go to Q19, which I think Q19 is right here, this guy. So green, you have like your primary, and then it comes, then your two other transistors are down a little bit. Ooh, barely, not even in the screen right here. These guys right here. So then we go, let's check the next one, Q19, which is this guy. So let's check the base. Nothing on the base. I'm gonna go about 2 volts per division. So we got like a 12 volt, but we have composite signal up here. I gotta zoom back out to show you guys. So I put my scope on 2 volts per division because now we're going to start amplifying. The signal is going to start amplifying. So that's the base. That's the base of Q19. Emitter. And let's look at that collector is low. So the collector actually goes to the base of the next one, Q17. So that guy's going to be low, but we should have some other signals here. Let's look at the let's look at the pot here. There's nothing happening on that pot. Well, I guess, you know what? It's going to be hard to follow that signal through. Without this game running, I don't know if we're going to get our horizontal frequency in on our 4066. So let's take another look at these. We should be able to follow our signal through though. Q17. Q17 emitter. Low. Base. Oh, that's 19. Oh, I'm sorry. Let's go to 19. So on 19 on the base, we do have signal coming in. Now the emitter is actually going to go to the emitter. This guy is going to go to this pot. One of the sides on that pot on the emitter. The base is going to be tied high, I think, to 12 volts. So we don't have anything. We don't have anything on this guy. Let's see. I wonder. Let me grab my screwdriver. I think we should be able. I think if the pot works, we should be able to see that waveform move at this point. Nope. Okay, I've done this before, but maybe it's the emitter. No. Nope, it is not. Okay, so let's follow it on. Let's follow it on to the amp, because I think it's the amp at what is that? I think it's the amp at 3P, this guy. So and he's got that weird shiny package that I don't like. Pin 1, 2, and 3. Let's check them out. High, like 3.5 volts. That's like a weird drop. See it dropping? That's pin 3. That's the input. That's one of the inputs. That was weird how we touched it and the voltage come down. Let's check. Well, I guess the good chip does that too. So let's. What I want to do here. Let me come over to the. Let me come over here to another good one and compare. Okay, on the pot there. Let's see. I'm on blue of the working side, and let's see if we can. Yeah, see. Okay, I'm not crazy. You should be able to see the signal increase and decrease. I think you're on the output side. Call it the output side of this pot. I don't know if you can. Hopefully, yeah, you can see that moving. We can see that moving. Now let's try. Let me try blue over here. Without the game running, we might not. Yeah, see, we're not going to be able to get anything out of these pots until we get this game running. Okay, so trying to decide if I just want to pull this 3P right out of the gate. I think we will. I think we're gonna pull that 3P right out of the gate. I tell you what. Let's get this running first. Let's do the RAM. Let's do the RAM first. Get it running, and then that 3P I think shares a color with side 1, and then we can kind of see if there's any color differences that might help. For sure, let us know which one of these, what's going on down here in the video section. Yeah, it's either the 3P, this guy, the 324, or I don't think it's the pot. I don't think the pot's bad, or we kind of like in that other board, maybe one of these capacitors is no good. So I'm not going to film this. I'm not going to film taking out the RAM. We just did that on the last video. If you want to see how to remove these, watch part 7. But I'm going to pause here. I'm going to pull this, get a new RAM in, clean it up, and we'll fire up together when I get that done. All right, be back soon. Okay, we got our new RAM chip in right here. Replaced it with HN6264 8x8K RAM. So let's power on. First time, guys. Let's see what we get. Oh, we got nothing. We got nothing still. We have nothing. What does that mean? Okay, so let's come back over here to the scope. Let's probe around a little bit. Let's see if we have any kind of data. And that I was going to show you. I'll just come up here. Well, that chip did fail in the retro chip tester. That guy did fail. So let's probe around a little bit here. Let's get some light going. Let's probe around on the CPU. See what's going on. We are still dead. Yeah, we are still dead. We are still dead over here. We need to figure out what is going on. Okay, let's check our... Yeah, we are dead. We're not getting anything up there. Let me reset. I'm gonna do a reset. We are still dead over there. Yep, we are dead. That's crazy. I'm watching the screen. We got some weirdness going on. We've got the colors were kind of coming and going on this one. The colors were coming and going on Excite Bike. I saw green come on for a minute. Maybe it's just that amp trying to work a little bit. Yeah, that's there's no green, but still we got nothing on side A. Let's come down here. Let's get the schematics out. Let's see what's going on here. I'm wondering. Okay, let's check the reset lines. I think reset is pin 2. Let's see. Let's check the reset line on CPU. Yeah, if this gets too long, I might just cut and come back when I find something. Read write, reset. Pin 13. 9876543. 2 volts per division. Let's get it to 1 volt per division. Okay, reset's high on the PPU, which is good. On the CPU, where's the reset? Oh, 13. Actually, we want 13 over here. 9876543. Okay. Reset line, good there. And then pin 22. Pin 22 on this guy. 9876543. Why do we have... Let me double check. Reset. Is this PPU stuck in reset? We got a reset problem here. 9876543. Huh, we got a low reset on this PPU. And I think that says pin 13. Oh no, pin 3 on the CPU is high. 22, the reset. Oh, I was on 22. I was going 32 like a ding dong. 21, 22. Okay. Ding dong, ding dong, ding dong. Okay, so our reset's okay. I want to check. Yeah, we have clock, we have reset. Let's check our new RAM. We still have no activity. I wonder if this 6116 could potentially be bad. Maybe. We might end up pulling this guy and checking him. He would be the first, actually. He would... Yep, we're dead. All of this is dead. I wanted to check some of these. Okay, let's check 2K, 5 and 6. Well, that's the reset. 5 and 6. That's okay. The reset's okay. I thought there was some other 04 circuits up here. Something in the 04 circuitry. I'm looking at the prints off camera here. Basically, I'm just kind of looking around at some of these kind of standalone circuits, some of these standalone gates. I don't know if these guys could actually keep it from booting, but I'm just kind of probing around. I think I'm just going to keep filming. I'm just going to probe around some of these. I'll just call them off. 4A, pin 1, 2, and 3. Input, OR gate. So the output should be high, and it is. 4A, 11, 12, 13, 7, 8, 9, 10, 11 is output. So the next ones we should have one high and one low. Low. Oh, both of those are low. But they're inverted. So that's okay. That's okay. Oh, we could actually double check that by going to 5A and checking that as well. Oops. Yeah. Oh, yeah. So we're not. These aren't going to work without any signals. None of those are going to work until we get signals here. So we need to get in here and kind of see what's going on. See if we can find anything. Any smoking guns, anything flat or floating. Those are low. They're not really floating. I know I'm going through them kind of fast. Not really floating. They're just not being used. The reset. Now we already know the reset's kind of good. Let's check this 373. The 373 is like a buffer. It's kind of like a buffer between the PPU and the RAM. Let's see if, I mean, it's going to be dead, but we can check, make sure the signals aren't floating or just look way off. That would like indicate a bad chip. I think we may end up pulling that 6116. Let's probe that 6116. They're all high. This is one side. The 6116. The address side, they're all high. And then the data side. Yeah, there's nothing going on here. These are all low. Now there's some high ones. I don't know if that's a clock. Oh, is that 18? That's like the output enable. Let's see. 13, 14, 15, 18, 19, 20. If I have my cheat sheet out, let's see. 20 on that guy. Oh, 6116. Yeah, that's the output enable. Output enable is doing something. 21. That's the right enable. It's high. And let's go 18. 18 is the chip select, high. Everything else is kind of still dead. Yeah, we have a non-booting game here. I definitely don't think it's the RAMs. I definitely don't think it's the RAMs. Or the ROMs, I mean. So we're still dead up here. Okay, I'm gonna go ahead and cut here because I don't have the schematics up for everybody to follow along quite yet, or right for this troubleshooting section. But we're dead. Basically, the game, it's not even booting. The CPU, PPU, and the RAM is not working at all. Now we do have, and I haven't seen this to be a problem yet, we do have our boot RAM here, this 4816, but if one side is working, I couldn't imagine the other side not working with this guy. Yeah, I'm watching the scope and I don't really see a whole lot of activity on there, to be honest. Okay, guys, I'm going to cut. I think the next thing I'm going to do, just for my own sanity, I won't be happy until I get that 6116 out and test it in the retro chip tester. So I'm going to get that guy out and see what's going on, and then we'll cut back. Okay, cutting back after checking some things out here. So got some things to catch you up on. My camera died, so I did do a little bit of work off camera. So we're going to start with where we left off. This 6116 that was here, it was bad too. This guy was bad. So we put this guy in, and I'm just going to probe around. I'm going to probe down at the address lines, and now you can see, now we have activity. Now we're in the game. Now we are in the game. Let's probe some of the address lines on the program ROMs. We have nice clean activity. Now let's do the character ROMs. We have activity. So really the game should be running, right? And now let's look. We're looking at side A, the top screen there, or the top monitor, and we still have nothing. But don't fear. Don't fear. I think we found the problem. Okay. So with that being said, bad RAM. Now the microprocessor and software is running. It's running just fine here. So it got me thinking, what is going on? So I moved my attention over to the video section, and kind of like how we started the video, we did our pre-checks. So we have red, green, blue all coming in to their circuits. And I kind of went through the op amps, the 324s. Those kind of all look okay. And then I got to taking a closer look at these switches here, at the switches. I'm like, okay, if missing, one gate, we would have a little bit of something. It has to be maybe something to do with the horizontal frequency. So if we come in here, we can see that we have at 2P and 4P, these share the same IC, 4P, and 2P. Pin 13, and pin 5. This is where your horizontal frequency comes in from your sync. Your sync comes in here to the sync circuit, kind of comes around, goes out to your sync, but it also comes through some resistors, a transistor, and it comes in, and it will kind of, how do I think of it like it merges your vertical sync in with your color lines, and then that's how the screen knows how to write the images on the screen. So let's look at these. Let's look at the horizontal frequencies coming in here. Let's just start off 2P, pin 13. So we're going to come up here and get some light, proper light. 2P, this guy, pin 13, right here. We are flat. Let me get out here. So we are flat. So let's go to 4P, 13. We are flat. And what was that other one? Pin 5. Was it pin 5? Pin 5 on 4P. Pin 5 on 4P. And it is flat. Well, the good thing is we can compare. We do have a running side. So let's look at the sister side of that. Let's look at the sister side of that. So let's look at side B, the second side. Let's look at 2P, and 4P. 2P, 12, and what is that, 5? 3, 4, 5. 2P, 12, and 2P5. Let's look at those. 2P12 and 2P5. Back on this same chip. 2P12, 4, 3, 2. I don't know if you can see that. We have horizontal frequency. 12.5. That's about where we need to be. Pin 5. 1, 2, 3, 4, 5. You can't see it real great on this scope. Let me slow. I got both my hands tied up. Let me slow that down a little bit. Maybe we can see it better. 5. A little bit better. Let me take that down. Let me take that down to 2 volts per division. Maybe we can see it better. There we go. So there is actually signal there. There is a horizontal frequency there. Now I changed my time base so the frequency doesn't really catch where I have it set. But anyway, we have frequency there. So we can prove that we do not have horizontal frequency coming in to the video switch pin 5. So let's look at that. Let's look at that, what that kind of means here. So here's the sync. It comes from the PPU, and we can just start back here at the beginning. Pin 21. We have a sync signal. Let's look at the sister side. So that's the Excite Bike side, the side that's running. And that's the side that's not running. It's running, but we're not seeing anything. So we have sync there. Okay, so we have, let's just follow it around. PPU sync from here. Comes down, and it comes into the sync circuit. So I started here. I've just kind of started just at the beginning and going through everything. Following the path, Keith. What are you trying to say? Damn it, get it out. Okay, following the signal, coming in through here, and I followed it to this 1L. Guess what 1L is? It's one of these nasty 04s that I had profiled earlier. So let's look at the input and output of 1L. So the frequency comes in here. See, it's got to pass through this gate. It's got to pass through that hex inverter to make it down through the rest of the circuit to the JAMA output and back around to feed all 3 of these switches here. So what are we looking at? We're looking at pin 10, 11 in, 10 out. So 8, 9, 10, 11. Okay. Oh, wrong chip. 8, 9, 10, 11. All right. So there's our sync signal coming in, and look at what's going out. It is high. It is stuck high. There is nothing coming out on that 04. There is nothing coming out on that 04. In. Oops, excuse me. In. Hard to see. Apologize, but you can see a waveform there. Out. We are high. Now let's confirm that. Let's see what the running side looks like. So let's go down to the sync circuit on side B. Let's find that same area. So 1L, same chip, pin 5 in, pin 6 out. So let's look at that. 1, 2, 3, 4, 5. Okay, there's our in. We have a signal. Pin 6. And there's our out. We have a signal. Now that side's working, and I think that's why we have Excite Bike. Well, one of the many reasons we have Excite Bike. The sync circuit is able to complete. So definitely this 04 is bad. Let's get him out of here, and we'll replace him. And while we're at it, we're going to do the same thing. We're profiling again. This is the same crappy manufacturer of 04 chip. I don't know if you can see it in the light, but they're kind of a different looking color chip. They have like a brownish shiny case, and they're not good. I'm not sure where these are made, but we're going to get him out of here. We're going to get both of those out of here. And I've noticed as well, something to note as we go forward, green. I've got green coming and going on Excite Bike. Green is flaky. And I don't know if it's maybe the edge connector. See, like right now, I think we have green back actually. Oh, see, it's kind of changing. We have green. Oh, see, it's just kind of flaky. So I'm glad I did not take these out of the gate. We may not even have a problem in our video circuit, but let's get those out of here, and then we'll cut back and see if we have anything up on side A. All right, be back. Okay, we're back after a little bit of rework on this board. So I pulled those 04s, and I can show you. I pulled them both because I do profile, and one was good and one was bad. I'll show you. Yeah, that's the bad one. So that guy was definitely bad. And I think this one's good. Yeah, that one's okay, but I still don't like them because they'll probably fail soon. Yeah, bad 6116, bad 5533, and actually out of my own stash, I had 2 bad 6116s as well. These have 2 of them that will not pass. So, okay, onward and upward. We are ready. Let's get ready to power up here. Let's get the power supplies going. I like to let them warm up for a second. All right, you ready? Here we go. There's the 12, -5, 5. Oh, and we are booting to garbage. Okay. Yeah, okay. Hey, we got something going. At least we have our visual back. I wonder. I'm kind of wondering about this RAM. If this RAM, I could not find the data sheet for this it's an ALSP12. I don't know if that's 120 nanoseconds. The original one. Oh, Mario is playing in there. I just seen him running around. But this data sheet comes back at 150 nanoseconds read-write time. I don't know if this is a write thing. I think I'm going to cut again. I think I'm just going to look for some more RAMs and maybe mess with that RAM a little bit. Ooh, yeah, he's not happy at all. Before we do that, I suppose we can. Let me grab my probe here and let's probe around a little bit. Let's probe around a little bit. Let me get this guy kind of set up on the block, the chopping block, and let's probe around a little bit. Let's probe around on that RAM. I'm going to see kind of what's going on. I don't see. All right, there's some data activity. I need to grab my cheat sheet and see exactly. I need to see exactly what these pins are. I think one side is just kind of like an in and one's kind of like an out. I'm not seeing a lot of activity on this RAM at all. I don't know if I'm liking that. Yeah, we have something else going on. I think that's one of the output enables or write enables. Let's look at this 123. Or I'm sorry, 138. So this guy, we should have activity for the chip selects for the ROMs. We have no activity there. We have no activity there. This side we should have some address bits. Man, it's almost like this thing is not running again. Let's just hit some of these. Yeah, we have no data or anything still. I don't know if that side. Let's reset that guy. Mario Brothers, you kind of see him. You kind of see it there. Mario Brothers. Okay, I bet for now we have some data. Now we have some data, something to go on. That RAM is working. I'm gonna get these chip selects. Yeah, we're getting, I know it's awful, but we have some letters up on the screen. The game is kind of running. And this RAM, even though it checks, it looks really beat up. I'm almost thinking about throwing another RAM in there. But let's just keep looking around here, see if we can find anything. I don't know if that's a contact issue with the sockets. That signal kind of looks weird. Oh, okay, I guess it went kind of normal. Let's check this what is that, 373? Get some light over here. Yeah, this 373. Just kind of go down and probe on him. I guess this is what you call probing around. Just kind of probing around, looking for bad signals, kind of a chip at a time. That one looks kind of weird. Where was he? It's a really grimy board too. I mean, this thing has been washed, but it still has a bit of grime on it. You can tell when you probe around, you got to kind of scratch down to the metal. Get on a couple on these rams here. Let's do these rams. Let's go down let's just go down, see what's going on. No signal there. I think some of these are, oh yeah, see, we flaked out. We flaked out. Let's see if we can get, it's coming back. I might try to reseat these. Just to have another inspection on them and see what's going on here. And I'll get my cheat sheet out for the pinouts. I like my cheat sheet because I don't have to have the schematics out in front of me. Yeah, see, it's not happy at all. It is not happy at all. I think we're working with something in this area, though. Maybe even some of these, maybe even have more bad gates. Okay, I'm going to pause again here. Let me continue to look around with the schematics, and I'll come back. I'll come back when we have a smoking gun or something interesting. Okay, guys. Hey, we are back. We are back on this board. And I've been quite busy with my day job. So last we left off, we had nothing on side 1. So side 1, okay, let's just start. We got all kinds of weird things to catch you up on. Okay, first things first. We didn't have anything on side 1, and I went after the 5533, still nothing on side 1. And I changed the 6116, and it actually came to life. Then this whole CPU side, processing side, started working, and then it was just flaky. It was just flaky, and really, okay, maybe I lied. I needed to film more. Actually, side 1 was not working. Changed both of these RAMs, still had nothing. So I went after this 8416. I changed that 8416 and side 1 came to life. So that's lesson number 1. Only one side can go bad with this bad 8416. I was kind of under the impression from the schematics that if this RAM was not good, that neither side would work or both sides would have problems. That is not the case, because side 1 worked just fine. Or side 2 worked just fine, but not side 1. I put the new 8416, and then side A came to life. So I was actually just letting this thing run, and Super Mario was looking pretty good. And I was going to start the video with side number 2 here, because we have problems on side 2. But from yesterday's testing, I know we have problems on side 1. So pretty much, I think what we have going on side 1 is bad sockets. Yesterday when I was testing, when I move that PPU around at all, then the side 1 goes bad. It don't take much for side 1 to go bad. So that's on the list. We're going to put new CPU, new PPU sockets here. So let's check out side 2. Let's get kind of caught up where I want to be for today. So side 1, it actually looks okay, right? But it's not okay. That's not okay. Let me get the camera kind of set here where we can see what's going on. So let's coin up and play. And we're going to see sprite artifacting start here at the bottom after we play for a while. See, right now, both sides are playing fine. We got another possessed board. So let's play this until the flakiness comes. I like this. Oh, there it goes. There it goes. It seems to be when the CPU and PPU or those RAMs, one of the RAMs is maybe bad, but I still think we have connection problems. And you can hear the audio lagging, actually. So the game is running. The game is running, but we definitely have graphic problems. Let's start another game, or the next round. Yep, there it goes. And the audio's lagging, everything. Oh, see, it's kind of reading and writing to the wrong spot. So what we got, what I believe we got here. I've kind of seen this before on that one Super Mario Brothers we did. One of these RAMs could be failing. One of these RAMs could be failing, and maybe bad connection. And these feel hot, to be honest. These feel hotter than normal. So I don't know if that's bad contact causing more amps to kind of get drawn. Maybe bad contacts is drawing hard, the current. This one is definitely hotter. It is more hot. It's hot. It's hot. Both of them, the CPU and the PPU, is hot. So maybe those guys are just getting overheated and lagging out the processing. So let's just take it a step at a time. I'm going to cut. We're going to replace all 4 of these sockets. We'll come back and we'll see if we get that laggy thing going on side B. I don't think it's a ROM problem. I think it's a CPU or RAM problem. So let me cut off here, get the goot heated up, and we'll continue. Okay, we're back. We're looking at the sockets that I pulled. Let me zoom out here. Alright, so have the game running, but let's look at these sockets first. These 2 are side B sockets. These 2 are side A sockets. So I don't think it was side A giving me the problem, I think, with the bad contacts. And side B, maybe not so much, but we're going to zoom back in and I'm going to show you what I found. Nothing groundbreaking, but side B, see, they're shinier. They're shinier. Right there's where they're not just sitting next to each other. And the side A have that dull, oxidized look to them. And also I got them leaning where we can look at the gap in there. These may have had daughter boards seated into them. You can see where they've been kind of rammed open there at the bottom where they go into the case of the socket, the plastic case. So we'll just do a drive-by. That end pin right there looks a little bit corroded. But we go over to the B side sockets. See, they're shinier. They don't have that dull look. But the game is running much better, actually. In Mario, there's no graphics problems now. Okay. So that's excuse me, that's what I found with the sockets. No need to go into that. And I had the RAMs sitting here because I kind of forgot to tell you. All those RAMs I changed, Every one of these was bad in the retro chip tester. The 6116, the 8416, and the 5533. So this guy, the 8416, the 6116, and the 5533. Bad, bad, bad. I'm kind of wondering, how does that happen? How does all of them go bad at once? It's kind of weird. And with the glitchiness on Excite Bike, I adjusted my power. I think maybe I bumped my power supply. The voltage was almost a half volt high. We were at like 5.5, 5.5 volts. I turned that back down to 5. Seems to take care of the glitchiness on Excite Bike. But something I've been monitoring since I started this repair, and I thought it would sort itself out. And I tried to record it before I made this recording. I can see Excite Bike here in the background in the blue. You're just going to have to trust me. Like when it starts moving, you can't see it so much. You can't see it at all. Maybe like when the frame is still, depending what frame that is on, especially in the high score part, you can see it in the background here. And I've been thinking about that, what to do, if to do anything. It's so slight, but what you can see that I noticed about this board too, I'm going to have to get better pictures of the CRT. I apologize, guys. You can kind of see it. There's like a different color blue. There's like a blue kind of streak right about here where my finger is. Right about here where my finger is. And it won't go away. And I don't know what to think about that. So I think what I've been doing, I've been probing around. I think what I'm going to do, yeah, right here, I don't think you can see it. You can kind of see some of the grandstand of Excite Bike, like up through here. Yep, because we're scrolling now. Now we're scrolling, and some of the words. Right there it goes. Whoop whoop. You can actually read it. I can actually read Excite Bike up here on Mario. That scrolling is up on the A side. So I got to thinking, what would cause that? Let's go to the schematics. So the video section, these op amps that we've already changed a bunch of, these color gates for side 1 and side 2 actually, let me shut the fan off there, I was soldering. They actually share some of the same side ICs. So let's go down to side 2, for example. So we have 1P, 3P, and 3P. Now we come up here to side 1, we have 1P, 3P, and 3P. So both chips share both sides. So I don't know if we have a failing short inside of that IC, inside of the body. Maybe it's leaking. It's leaking its amplitude and frequency over just enough to carry a little bit of the signal out to the screen. So the second thing I kind of thought of are these video switchers here. These video switchers, they're positioned the same way. The 2P, 4P, and 4P. Then over here on this guy we have 2P, 2P, and 4P. 4P, this switch here. But that carries the horizontal frequency in, kind of feeds those amps. So I got to thinking, if a horizontal frequency from the video switcher was leaking internally, one of these guys was bleeding over into one of these guys in the same chip, maybe that's what's causing that. So I was thinking like how to do that, like what's the best plan of attack, and that's these 4 guys here. 1, 2, 3, 4. That's these 4 right here. So I think what I'm going to do, call it a social project, a social experiment. I think I'm going to remove every one of these. I think I'm going to remove every one. Okay, first, back up. After I stop filming, I'm going to go ahead, I'm going to inspect this whole area visually and kind of probe around. Make sure, like on the back side, there's not a short, something leaning over and touching. And if I don't see that, I think I'm going to desolder every one of those and then put them all back into the sockets and then change them out one at a time to see if I can't get the A video to look a little bit better. So I think that's the plan of attack there, but I think this board is getting pretty well done. I will add that this CPU and PPU is still running hot. After I put it in the new socket, after I put these in the new sockets, these are still maybe almost twice as hot. Not quite twice as hot, but the heat sink and the CPU, I mean, that's cool to the touch. That's cool. There's no heat there. This guy has some pretty good heat up on the heat sink. Could be the PPU, who knows. But the CPU also, to the touch, is quite a bit warmer than the side A. So that's the catch up here. And yet another part, I kind of want to be done with this. And another thing, I don't even know if you can see it. So Nintendo, these jail bars, you can't even really see them. They're normal for the Nintendo boards to have these jail bars, and the jail bars even look a little bit weird. So the jail bars are horizontal. You can kind of see them. Cannot see them. You can see them in person. Whoop. But the jail bars, yeah, you can kind of see them here. Those are normal to Nintendo, especially in the NES systems too. But those jail bars are kind of weird too. They kind of disappear sometimes. There'd be like a block section disappeared, and I think it has something to do with the bleed over on those. Now this is my 7th board, and I have not seen any kind of image bleed over. See, now this is where you can really see it. It's scrolling down there, and I can see a little bit of the words. I can see some of the lines, like right here. Here's the box. I can see it. The checkered box. I can see it up here. So, yeah, right here. Boom. And it's going to go away in a second. Boom. Ah, well, I changed the screen. So let's do that. I think I'm going to pull these 4, good or bad. I don't know. Let's see if we can fix that and take care of that weird shading. Hey, and I want to go back to the beginning of this repair. Remember we had no green? So the no green deal, and the no green deal, yeah, no green deal now. But the no green deal was a dirty edge connector. And I'm going to slide this stuff out of the way, and I'm going to show you the back of this board where I'm talking about this. And then this is the other thing. I don't know. Maybe we'll circle back around to this towards the end of the video. So on the back of this board, this is my 7th board, and let's see if I can. There is like a weird corrosion. See the black? See the black flaky? See the black flaky there? That is a weird corrosion. And I've worked on a lot of boards that have, I call it petrified solder, powdery, it's dry, electrolysis, stuff like that. This board is kind of like that on the back. And I thought it was the capacitors, the capacitors in the control section for the pull-ups. There's like a bunch of them right here. I thought those were causing it and leaking, but I inspected the part side, and there's nothing. The part side is perfect, and you can see it here. You can see it here, and some of the stuff I have desoldered, it came out really hard, way different than the other 6 Nintendo boards I worked on, and you can see that black stuff. that black kind of electrolysis stuff. And I've washed this board, and then yesterday when I saw it, like right up here, you can see the black, the powdery electrolysis, something. This board laid in something, it got moist, something happened to this board. So if we zoom out, like I would say like right about here and over, it's pretty good. I mean, there's still evidence of that stuff. There's still evidence of that stuff over here on the left side. I think it's some sort of electrolysis. Oxidation, something. And I almost boxed this board up for a spare board, kind of looking at these traces, but the game works. It works. And I was wondering if some of the problems that we saw with this wasn't due to corrosion, but I don't think it is. But I don't know what socket I grabbed here, but it's kind of like some of that stuff made it into the sockets on side A, not so much side B. And kind of wrapping this up, that same nasty electrolysis corrosion was on the JAMA edge, was on the connectors there. So I took this apart, I cleaned it, I cleaned the living crap out of it, and I tell you, it's not as nice, still not as good as I want it to be. It's clean, it's making good contact, and we got green back, but I wanted that to look a little better. If I were home, I have a bottle of liquid silver, liquid tin. I would have hit those with the liquid tin. I don't think I'm gonna re-tin those with the solder gun or anything, but yeah, just a kind of a nasty board. Just kind of a nasty board. It works, but I'm not real happy with this one. I'm happy it works, but I'm worried about the longevity of this guy. It'll probably be fine. It's been neutralized. And I don't think the corrosion is going to come on anymore, but I sure don't like the way that looks. At least we stopped it. We stopped the corrosion or whatever was attacking that, and that's good. So I think we're going to go after Mario next and try, well, we're going to go after that video. You can kind of see it right there. That blue line. It's never been there on the other games. I use the same ROM set for every board. So I'm going to cut here again. Going to take those guys out. Yeah, I can see it. I can see that up here. You can't see it in the video, but I can. And it bothers me. So let's try to fix that. Okay, we'll be back. Let's get that. Let's get these guys out. 1, 2, 3, 4. Got the trusty goot. Let's go. Okay, guys, we're back. So I threw another game in here, and I kind of got my camera fixed. Now you can see. Well, I thought you could see. You can see the letters. We still have bleed through. So I removed all of these video amps, the video switches, and changed them out one at a time. And we still have bleed through. We still have bleed through on the screen there. And it actually is a little bit better. I can see it pretty good. It's still there. You have to trust me. I'm not crazy. That high score list is right here. I can kind of read. I can definitely read it up here. So it's not that. And I don't think I'm crazy that there's a problem here. I feel like I'm crazy because I'm looking at the schematics. I'm thinking, okay, where can these video signals be bleeding through? And I've been taking resistance measurements. Okay, so here's an option. The variable resistors in each one of these transistors come up and hit on the 12 volt and the ground line. So we could have, man, I'm looking at this thinking, man, we could have lots of bad parts, or it could be a lot of different things. Variable resistors, all three colors all three and both sides, the variable resistors all land. They go up to the 12-volt rail and a rail that's kind of ground pulled low. Yeah, pulled low through capacitor 88. This guy. So, oh man, we're just looking at a bunch of parts now. Capacitors, maybe a leaky transistor, a leaky variable resistor. We have lots of parts to look at, and I have probed around like crazy, taking resistance readings on everything, and I no smoking guns. If there's a slight signal duplexed, which means two signals kind of riding on the same line or same bus, a video signal, it's going to be really hard to see. Like, for example, I don't know. The Q17 here has got my attention a little bit, because when I probe on the base of him, Mario kind of goes fuzzy, and the background seems to lessen a little bit. But and he's the only one. If he's the final output for green, now if I do his matching one up here on the other side, like my friend Josh said, if I ping pong over to the other side, I don't get that weird static from the impedance of the scope probe. And kind of looking at that signal, I know I got my slew rate kind of high there, but that's on side 2, and this is on side 1. Side 2 almost looks like there might be a little hidden carrier signal in there, but I'm not sure. I'm not going to say yet. So I think what I'm going to do, not that I hate to spend a lot more time on this guy, but we definitely have a problem. I mean, I can look right up here and see. Now you can kind of see it right here. See that? That's the scoreboard from here. So we're bleeding through, and now we know it is not the switch, the video switch, and it's not the amp. So it's got to be happening somewhere else. I don't know if it's carrying across this 12-volt bus and carrying down through the variable resistors maybe. And I do have kind of a weak green here. Weak green, I call him weak green. This is a 500 ohm pot, and he will only max out at 450, and all of his brothers and sisters here of all different colors, they will go to 500, but not green. And plus we have that kind of weird signal on green here, and then the green transistor definitely getting some fuzziness, some artifacting when we add impedance on the base of him. Ah, boy. Plan of attack. Here's what I'm thinking. On the other boards, we already found really bad capacitors on the board and the video signals. This first capacitor here, really bad. Really bad. They were just failed, almost shorted. And so I think what I'm going to do, I think we're just going to, first of all, we're going to recap this whole section, and we're going to recap it, and we're going to change these 16 volt 470 microfarad capacitors, see if we can't clean that 12 volt bus up, and that will kind of hopefully unravel the mystery here. And then we can kind of go, if we see anything, maybe that'll make it easier to see if these transistors or resistors even, because we could have some failing resistors here kind of causing that too. I might just be crazy. Maybe it's like that on every game, but I don't think it is. Right there you can kind of see it. And yep, right there you can kind of see that scoreboard. And I can see the dots as well up here. So we're going to keep plugging away. I'm not putting this thing away like that. So lots of parts, lots of work trying to find. Hey, but something cool just happened too. I just received, literally in the mail, a dude on a little scooter came up, and I got my PPU changers from what's he go by? Morticia, I think. Is that Morticia guy? But I ordered a handful of these PPU changers because of this right here. Because I have a bunch of these RC 2C05-4s that come with Gumshoe, and these are specific to Gumshoe. And I've got like 6 or 7 of these. Awful game, and I have a bunch of those PPUs. So basically, this PPU changer will allow me to use a different PPU for the different game. That's another reason I threw Clue Land in. This requires a 04. It's the same one as this. It requires an RP2C04-0004. This ROM set requires the same PPU, and it works. So I put it in here. I set the dip switches accordingly, and we have Clue Land running on a different PPU. That's not the point of the video, but I just received it, literally, just about an hour ago. So I thought, oh, what the heck? I'll throw in another ROM set. Maybe I can validate, the bleed-through problem and kind of start populating these boards with these very specific PPUs. But more on that later. I'm going to make a whole video on these later because I think those are pretty cool. So I'm going to cut here, I think, for the night. I have to run down to the electronics shop, stock up on these 16-volt, 1610s. These are 1610, 16-volt, 10 microfarad capacitors. I think I have a couple of these, and it didn't take me that long last time. We're just going to do this whole section and see what we get. I'm curious. I'm curious what we get. Okay, we're going to pause there, and we will be back. Okay, guys, we're back on our way to fixing our bleed-through problem, and I think we got it fixed. I went ahead and recapped the whole board, minus the pull-down resistors for the controls, and I ran out of 470 microfarad 16-volt capacitors. But I did get the important ones over here on the 12-volt lines, which, if you look at the schematics, where the transistors and the variable resistors kind of all share bus activity or 12-volt activity for pull up or pull down that are common to both sides of the video system. So I've had the game on for a while. Here we go. I know you couldn't see it before, but you have to trust me. It is not there now. There is no bleed through. I've had it dark in here. I've played with the color. You could read the high score board up here. There is no bleed through now on side A. So, without changing out the capacitors one at a time is kind of hard to say. It could have been the 12-volt line ones. It could have been, boy, who knows? Who knows? But there are a lot of capacitors in these circuits that tie, that where you end up here on the 12-volt lines. Who knows? Who knows where it was? Maybe it was coming in through a 5-volt line or the ground system. It could have been, they could have been bleeding over into the ground. Who knows? Well, if that ever happens again, I don't think I will go after the op amps, the inversion amps, or the switches right away. I think if I see that again, I'll just go after the capacitors. So I think that's really going to bring this repair to an end. We have sound. Both sides sound good. So I guess when we recapped, we also recapped the audio section too. I don't know. Let's coin one side up here. Oh, I guess we have to coin. Let's start again. Clue Land music. Sounds pretty good. And I went ahead and I glued on the heatsink to the PPU on this PPU changer. It's a Gumshoe PPU. Can't really see it here real well. MDS-04, now she has a purpose in life. Thanks to the PPU changer, we can put all these gumshoe PPUs to work in more popular games. So I think before I box this up, I'm going to get my test set out of here, and I'm going to populate Mighty Bomb Jack on side A. And I think I'm going to let it run. I might come through, give it some more cleaning, but all of our rework, it just looks great. Board is super clean now, minus that weird corrosion. And I think it's time to move on, guys. I think that's about it. I might cut in one more time with the Mighty Bomb Jack, and we'll go from there. Okay, we're back with the wrap-up portion of this video for this board. Thank God. Holy crap. Yeah, this board was a mess. Okay, since the last cut, I repopulated it with Mighty Bomb Jack, and we already had Clue Land in. So coming down on the board, I used one of the PPU changers I just got, and I'm actually using a... I'll just show you. RP2C03B for Mighty Jack. And then adjusting the dip switches, get the proper color, and off we go. Now there are different ROM sets for Mighty Bomb Jack that will let you use Mighty Bomb Jack with different PPUs. And I don't understand. I think one of the websites calls this PPU being able to use this Mighty Bomb Jack with a different modded ROM set. But we're running it like that. I have extras of these. It's actually a duck hunt, which I already have some duck hunts populated, so I don't need any more of these guys. And then over here, we already did that guy. Okay, let's wrap this guy up. And I'm just happy that there's no bleed through on the A screen on side A. And what that turned out to be were the capacitors. After I recapped the board, that bleed through went away. So let's run down what we did. It had 3 bad RAMs. It had bad 6116, 5533, and the 8416, all bad. And we had bad sockets on side A. The PPU socket and the CPU sockets were bad. The ROM sockets were bad. I think I changed out a couple of... No, did not change any ROM sockets over here. Only the PPU and CPU sockets got changed here. What else? During troubleshooting for the bleed-through problem, we ended up socketing the video and the video ICs, the video switch ICs, and the inverter amp ICs. And I think that's about it. I lubed up the pots, the video pots, tested them. Audio was good. I did remove the battery pack. It had corrosion started, and kind of know how I feel about that from the last video. If they start on the inside rivets where the positive and negative wires are, I'm just going to take them out, because eventually that will make its way down to the board. And until the time we need some sort of battery backup here, we'll install one in here later. And I think that about does it for this board. I think it's time to get to the next board. I'm going to let this guy run for a little while, make sure that it's not going to get crazy or start resetting or something. But yeah, we're looking pretty good. I took some time off between the last cut and got cleaned up a little bit. So I think one of the next boards, I really want to get this Bungling Bay put into one. Ice Climber, I put this in a couple times and I can't get this to work with the CPU I have. I'm going to have to double check, make sure this is not the 2-player version of Ice Climber, and maybe that's why it's not running. Or maybe now with the PPU changer I can get a PPU to work. Excite Bike for test set. Have a golf to populate, but here soon, maybe even on the next board, we're going to go after some of these daughter board games. These are the ones I'm really excited about. Graduates, Castlevania, Goonies, TKO Boxing, and the Super Sky Kid. It's going to be fun. These next ones are going to be really fun. Then we're going to circle back to the gun games, and I got to figure out how to get this guy connected up so we can bench test the shooter games. And this, so far, this is like the bad boy pile. And I've thrown away a lot of chips too, but those are the ones that made it onto the bad parts pile there. So we're getting there, guys. We're 7 of 12. Now we're going on board set 8. Thanks for watching. Me, Keith, Elder Rock, Arcade Laboratories. Make sure to keep checking in. Hit like and subscribe. I really appreciate it. Comments, love that even better. And okay, see you guys later. Bye.